Hello everyone, welcome back to Quick Revise. Today we will be talking about force and pressure. Force and pressure is a topic on grade 8 from science, and we will be covering both force and pressure and some tips for your exams. So let's get straight into it. Force is a push and a pull. The direction in which the force is moving is called the direction of force. As in, if I have this pencil and I push this pencil like this, then the direction of force will be towards the front. So this is important for questions where there are two forces acting on one object. So for example, if I have one pencil like this, here we can see the first example is there is a box and 20 newtons is being pushed here and 20 newtons is being pulled. So both of them are acting on the same force. So this pencil is here, I am pushing from this side and I am pulling from this side. So both of these forces are acting towards the same direction, which means that their resultant force will be the addition of both these forces in Newton. Force का ऐसा unit as in the standard unit of measurement for force is called Newton. And if there are opposite directions, then the resultant force will be the subtraction of both the forces. So if I have a pencil and I am pulling the pencil from here and I am pulling the pencil from here, then what is happening? The pen is on either than the greater force. Like for example, if this is 50 newtons and this is 10 newtons, then the pen will move towards this side. The pen will move towards this side. Why? Because the opposite direction will subtract it. So the total force will be 40 newtons acting towards this way. The this is the major for resultant force. How to solve resultant force? There are three types of contact forces. Muscular, which is if I, for example, if this pencil is kept here and I pick this pencil up, this is called a muscular force, as in I am using muscles to exert force. Then we have mechanical. If I am I'm opening lid from this pencil, then you can see that lid is coming out. There is no muscle being used to physically pull the lid out, the tip lead out. That means that this is a mechanical force. Another example is if you see in a helicopter, then the helicopter's propellers on top is all mechanical force. A car's tires is mechanical force. Why? Because no human muscles or force is being exerted to move the tires or rotate the propellers. The third type is called frictional force. This has another chapter in itself, but they'll give a little glimpse of this in this chapter. Frictional force, as in the force that opposes your motion. So if I have this pencil right here, and I push it like this, then the pencil stopped. Why did it stop? Because there was a force acting opposing this pencil that made it slow down in speed and made it stop. This is the same reason, like if we to give another example, if I had an infinitely long table, and I had a ball here, if I push that ball, then that ball would go till about here and then stop. Why would it stop? Because there is a frictional force acting upon it that is making it lose speed and opposing its motion, which is making it slow down and stop eventually. There are three types of non-contact forces. Gravitational force, the force that the earth exerts on us, which is if I have I think everybody knows about gravity. If you have a pencil here, if I drop this pencil, it went down. Why did it go down? Because there is a force that the earth is attracting upon us. In fact, every single object has a gravitational force. Even this pencil has a gravitational force, but it is very 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 small. Like it is 0.101. Like it is very very small, so there nothing can actually get attracted by this. If I have, for example, this cap here, then this pencil will not attract this cap because the gravitational force is way too weak to attack anything. and the scientific definition is the force of attraction between particles of matter. So anything that has matter has a gravitational force, and that force exerts on another piece of matter. Magnetism, the magnetic field that a magnetic object possesses. So if for example, let's say this cap was magnetic, then you must have heard North Pole, South Pole, magnetic fields are going around in like semicircles, and that magnetic force is attracts metal objects and other magnets. The third force, which I have not written here, is electrostatic force. Electrostatic force is the building up of charges in one or two. Like if I have this pencil here, and I rub this pencil against this. If I rub this pencil against, for example, let's say, if I have this glass, I have these specs. If I rub the pencil against these specs, then there will be eventually, if I do it long enough, a buildup of charges in the pencil, and the glasses and pencil will acquire charges. These charges are called electrostatic charges, or and this force that it exerts, so it will, for example, if this pencil gets a positive force and if you bring it near a negative object, it will attract that object. That means that there is a buildup of that force of attracting another object with north and south and all those like magnets and all that, or that force is called the electrostatic force. So this is all about force. Let's move on to pressure. The pressure has a formula to solve pressure. There it is force in newtons by area in meter square. So let's say if I had to figure out the pressure for, if I had this pencil here, I pushed it down on the ground, and this is hypothetical. If I said that the force I am applying is 10 newtons, and the area in meter square is 100 meter square. Okay, that means that the total force applied on this point over here is 1 newton. That means the total force applied here is 1 newton, 1 pascal. The total pressure applied on this place is called will be known as 1 pascal, and that is the pascal is the SI unit for pressure. If and there the way to figure out if pressure is going to be higher or lesser. Pressure is directly proportional to force. So the more force I apply on this pencil, if I push it down really hard, then the pressure also will increase. The more the force, the more the pressure. But if the pressure is inversely proportional to area. So the lesser the area, like if I press down on this entire pencil like this, less force will be applied, less pressure will be applied. But if I take this pencil and take the nib here, which is very small, and I only press down on this nib, then the pressure exerted will be higher, which means that pressure is inversely proportional to area. Liquid pressure, the lower the height, the more the pressure. So if I have a bottle here like this, and I have two holes, one is of three holes, one is here, one is here, one is here, then the hole at the bottom will throw out the water the farthest, like I have done in the diagram here. That hole will throw out the water the farthest, and this hole will throw it out medium, and this hole will barely lose any water because the pressure at the bottom will be the highest. At the same height, pressure is exerted equally. So if I have one hole here and one hole here parallel to this, then the amount of water thrown out from both of these places will be the exact same, because the pressure on both of them will be the same. This is the next page. Let's go on ways to reduce pressure. So like I mentioned, pressure is inversely proportional to area, and pressure is directly proportional to force. You can use this in this concept. Ways to reduce pressure: you can increase the area. Very simple. If you have a truck and that truck is, let's say, only running on one tire, then the amount of pressure on that one tire will be very high. But if you spread that pressure across 8 tires, for example, then the pressure on each of those tires will get reduced a lot. You can lower the force. Obviously, if this is a pencil, you're applying force really hard. But if you lessen the force, then the pressure will also get less. You can lower the area to increase the pressure. Ways to increase pressure: lower area. So instead of pressing down on the pencil like this, you can press it down on like this. You can increase the force. Obviously, you can, if you're pressing it very lightly, then you can start pressing it really hard. Actually left a mark here. Atmospheric pressure. Atmospheric pressure applies 1 kg of force per centimeter square. As in every single centimeter square on this earth, there is a kg of force being applied to it. We do not feel this because the force, because the liquid inside our body opposes this. For questions in your exam, there will be questions in this specific chapter, like there was a box, the F1, which is the first force applied. F1 is the first force applied. It will be like this. It will be F and then 1 will be written niche. If F1 was 5 newtons, if F1 was 5 newtons, and let's say this is the box, if F1 is 5 newtons and the box did not move, and F2 is the second force and the box moved, then what is the limit? And F2 is the second force, which is let's say 10 newtons. So the first one was 5 newtons, the second is 10 newtons. What is the limiting friction? So limiting friction का sign होता है FL. So you will write the limiting friction for this box will be 10 newtons, because limiting friction is the point at which, like, let's say the limiting friction of this is, if let's say this is 0.1 newtons, then the pencil is not moving, I'm still applying force, the pencil is not moving. But if I apply a little more force, then the pencil will move. That means that the limiting friction of this is the second force that I applied. Let's say that is 1 newton. So we can very easily say that the limiting friction for this pencil is the second force, or let's say in this case 0.3 newtons. Okay. So I hope you learned something today from this video. Come back for the next video next week, and good luck in your exams. Thank you.